Hey everybody, today we're going to be playing around with the O1 autocoder that I've built. Ever since I built it, I don't think I really explored it as much as I should. So we'll be doing that. I actually just as a test built this simulation. All I asked is if it was to build an environment simulation in Pygame, and it actually built this. So we're going to just ask it a bunch of stuff. Let's see what it builds. You can easily build over 1,000 lines of code. No problem. Look, it's raining. We can control the guy down there, but it doesn't do much. It also has a day and night cycle. If you wait a little bit, it should grow darker or at least change color. So you can see it changing a little bit. Let's see. By the way, this is 700 lines of code. Okay, see, it's growing dimmer a little bit. Actually, it wrote 10 iterations, and the 10th iteration is over 1,000 lines. But in this one, looks prettier, but the trees are at the top. And also the guy down there has legs, which is very cute. Yeah, this also, it can snow. There also has birds. It can snow and rain, all kinds of stuff. So we'll be experimenting with it and just see what it builds, what it can build. Yeah, so that's the idea. Look, it's snowing. It's really cool, actually. It says there's wind. Yeah. Okay, so let's turn this off and we can just give it let's run this and give it a task, multiple tasks, actually, and then we can play around with them. I'm going to go ahead and copy this and delete everything here, and then we'll run this. And let's ask it space simulation in Pygame without using any external assets. Let's start that. It's going to create the file names based on the instructions, so we should be able to separate them. They're all going to go into this responses folder. Let's create a new terminal and run this again. Python iterative autocoder. By the way, the source code for this is available at my Patreon. Link is here on Twitter. It should be as a comment. Look, if it, so by the way, it wrote the first of the space simulation game and it tries to run it and it actually will try to fix errors as well. So let's give it a second task. Let's say, let's again ask simulation of different in an ecosystem in Pygame. No external, please don't use any external assets. Let's start this. They're all going to go into the same folder. Let's start another one, and then we'll change these up as necessary. Python iterative autocoder. Let's see. Yeah, it runs itself uh, every so often to check for errors. That's what we are seeing here. See, like this is, it just ran itself. Features just grew too much. Anyway, we'll be able to see the iteration numbers here. They're just going to be numbered. Let's give it a third task. Let's say a 3D robot walking simulation. Let's say simulation in Pygame using no external assets, please. Let's start that. Let me start another cursor so we can run these without having to uh, type it from. Oh, I can't open it. Oh, that's sad. I can't open it in a new window. Okay. Well, why not? Because I would like to just run them by just pressing the play button. But I guess you can open the same folder in a new window, in a cursor window. And it keeps coming back to this. Okay, well, we're just going to have to. Oh, here is the creature simulation. We're going to have to split terminal here and do it like that. So we just go into the responses folder and we're just going to have to run different ones from here. So space simulation. Let's look at the third one. Already has over 500 lines of code. Let's run that. Space simulation. Which one are we? I think we have the fourth one now. Fourth one. Well, the fourth one has a problem. Maybe it'll fix it. Let's. So this is the space. After playing it a little bit, it has an error. We'll come back to this one. Let's play this robot simulation, 3D. It's on the second iteration. Okay. There's something in the distance. Zoom. Oh, zoom in. We can zoom in. It says W. I can't zoom in though. You won't let me for that. Simulation of different. Let's run the other one. Python. We are in the third one for this, I believe. Here we go. It's running very slow. Here is the game, by the way. It's just running it in the background as it's fixing the errors. So this is running very slowly. It says you can pause it. Up arrow to increase. Oh, here we go. This is the robot. Yeah, we'll have to run that again. We're gonna see them these popping out as we are, as it's actually testing itself to fix any errors. So this is the latest seems to be running faster. So let's run that, which is the fifth one. Sorry, the fourth one. Okay, here we go. So they're interacting with one another. It says reset simulation. If you press R, we can reset it. Up arrow increases speed, down arrow decreases. Let's reset and we can decrease the speed. Spacebar pauses it. We can add a herbivore. Oh, herbivores are trying to eat some stuff. Can add carnivores. So they are dying. It seems the carnivores and herbivores are chasing each other. You can see. I mean, the carnivores are chasing the herbivores. Herbivores are chasing these green dots. Interesting. It's still working on it. Let's. By the way, as it's writing its responses, it also writes the text responses that it has received from O1 Mini. So for each file, there is also the text that it actually creates, like a plan. So we can see those as well. Let's take a look at this 3D robot again. We are on the fifth iteration for that. Okay. So this definitely looks like a 3D environment, but I don't see a robot. Let's run the fourth iteration. So this is the fourth iteration. The zoom in doesn't work, but we can rotate it. Anyway, it's let's go back to the space simulation. We're on sixth iteration on that. Okay. Oh, So when we move, the whole space moves are. Okay, interesting. Can't actually shoot those things. I guess we did a space game rather than a space simulation. We can actually start another one. Let's go ahead and do that. Python. Oh, it's we have to get out of this folder. Let's ask for a beautiful side-scrolling. No, actually, let's see. A complex. What should we ask? If you have any ideas, do let me know. Um, let's again do the environment simulation. A beautiful environment simulation in Pygame without using any external assets. So it doesn't try to import any JPEGs or anything like that. Let's split another terminal. Let's take a look at this robot iteration 7, 600 CD. Let's go into responses and run that. It's actually at the 8th iteration. Let's run the 8th iteration. Oh, here we go. Well, there's certainly something there. You can move it with the mouse. It's going ahead. It's actually moving farther away from me. Space. If I press space, it stops walking. Move mouse to rotate camera. A and D plans. I can't zoom in. It's moving away from me. Yeah, so it did something, definitely. Interest. We are actually on the 8th iteration we ran. Let's take a look at different creatures simulation. So that's going to be the 7th iteration of simulation of different creatures. Let's see if it got any better. Iteration, simulation of different iteration. 7. Am I doing something wrong? Python. Oh, there we go. Okay, so that one is an error. Maybe it'll get fixed. Actually, we just got the error. No, it actually had a different error this time. Space simulation is on 8th. Python. Space 8th iteration. Oh, it put all kinds of settings. It actually has settings. How do we start the game? Game. Oh, I went on the wrong part. Hmm. This one's having issues. We are also on the second iteration of the simulation. Let's run Python. A. It starts with A. Actually, the third one just became available. Yeah, look at this. It does this pretty good. It says weather is clear, wind speed. I think the sun is moving way too fast. There's clouds. There's like these little planets moving around. I don't know what it's supposed to be about, but it tried to draw grass and stuff. Pretty interesting, indeed. So it's designed to run 10 iterations for each one of the ones we are running. We are using O1 Mini. It also prints as reasoning tokens. You can see like for this, it used 700 tokens. It writes the code, it runs the code, it tries to fix the error that it encounters. Otherwise, it just comes up with some improvements by itself, but you can actually interfere with it and like you can actually ask it to do it. Like you can enter your instructions at every turn. It waits for 3 seconds for that. You just have to press enter or something. I forgot spacebar or enter to be able to enter your at every turn. So one of them is done. 3D walking robot. Let's check that out. So this reached its yeah, and finally that error. Let's see how many lines of code it wrote at the end. About 767. The previous one was working, I think. 9. Let's try 9. Yeah, here we go. This is it. This is what it came up with. It's not very obvious what to do here, but there's a creature robot-like thing just moving away from me, away from the camera, that is. You can give it another task. Maybe we can ask it to make art or paint. Let's run the iterative autocoder and ask it to create a. Oh, wow. Okay. It's just, it runs at every iteration, it runs it for 5 seconds. If it times out, that means it hasn't encountered any errors, and then it just moves on. Create a art creation canvas in Pygame using no external assets. Let's start that. This one is finished too. This one was the space simulation final. Let's run that. 10th iteration should do. Start the game. Okay, it works. It's difficult to control. There's like some kind of a. Oh, I died. But I get it created a whole. What do you call a Hall of Fame? It's very difficult to control. Yeah, I died again. So, but it does all of this on its own. Oh, here we go. It just ran it without any error. The art one. We'll have to wait and see how that ends up being. Let's see. Let's run this again. Beautiful simulation of circles bouncing around with beautiful effects and user mouse controls, let's say, in Pygame without any assets. Oh, okay. The beautiful environment iteration has been having a lot of errors, I believe. That's why it kind of got stuck at. Okay, look, it's creating this. Create an art. Let's run this canvas that we asked it to create. We are on the second iteration for this. What is that? EL. Oh, line. Okay. Circle. This one doesn't work. Hmm. Interesting. Brush size. Can we increase it? Well, it's still working on it. Same time, we were also environment simulation. Let's run that. Iteration 7. Yeah, this is what we saw, but it somehow, I think because it's writing the temp code, this got mixed up with another, and the whole script failed because we are running four of them at the same time, and it writes the stuff to a temp file, I think, when it's executing, and that's what happened. Let's ask for a Python iterative coder. Let's ask for a Tetris game, fully functional Tetris game and Pygame without using any external assets. We can also run it here. What should we ask? First person shooter game and Pygame without using any external assets. Let's try that. Oh, actually, oh, okay. It's building a Tetris game. It ran the first time around. So this thing, it's not very good at art type of stuff, but beautiful simulation iteration 4. We can run it from here. Oh wow, this is actually changing. Changed quite a lot from when we started. Because it was nighttime. You can see the color changing as with the night. Now it's raining. It's dawn. Kind of foggy. Hmm. Oh, yeah. Let's play this real quick. We're gonna run Python. Beautiful simulation 5. It says trails on T, so we can toggle trails. Particles P. All right. Grid is a grid. We can reset it. We can turn off the trail, turn off the particles. Click right to remove a circle. We can remove them. Oh, here is the first person shooter, by the way. It's working on it. Left click drag. We can drag them around. See, that's interesting. Wow. Okay, so it's just doing all of this on its own. We can right click to remove. That's about it for now. It's still working on it. How many lines of code is it? It's 800. Art. Yeah, we were working on art creation canvas. This is at 900 lines of code. I've gotten it to generate 2,000 lines of code. Easy. It just has to go on for a long time. Let's try the art creation canvas. See if it had any improvements. This one actually has an error. The fifth one is working. You can draw on it. You can draw a line. rectangle, circle, fill. I think that's fill, but fill gives an error. So you can't detect the errors if during interactions, right? I guess you could modify the code so that it actually allows you to interact with it, but then it's not going to be as fast or autonomous. Apparently, it just runs it itself and runs it for 5 seconds. And if it finds any errors, it fixes it. Oh yeah, we were building a Tetris game as well. Let's see, functional Tetris is at 500 lines of code. Let's run that. Fully functional Tetris 5. And how do you? Yeah, seems to be working. Although some of these, oh, let's see. Yeah, the lines are disappearing. The This part is a bit. I think it has a. It's not perfect. Yeah, shows the next shape and everything. Still working on it. We did say 10 iterations, but where were we? Beautiful robot. We're done with that. Yeah. So uh, it can build all sorts of stuff. Can build it's designed to because it's executing with sub process. It's designed to run with Python code. It's difficult to you can easily modify this to so that it actually deals with HTML like canvas animations or things like that. But it's difficult to detect the errors from the front end. Is the issue? Yeah, we were building a FPS game. Let's play that. It's on fifth iteration. Python. By the way, like I said, the code files for this is available at my Patreon. I'll put the link in the description. If you're watching this on Twitter, it should already be in the comment. Python FPS game, fifth iteration. Press one for pistols, two for rifle. Okay, okay, we are able to. How do we shoot? Oh, I think I just killed something. Oh, two. Oh, enter. Interesting. Anyway, oh, there's even a mini map up here. They're following me. Okay, interesting. So you can do quite a lot, right? Six. How many lines? This is about 1,000 lines so far, and it's still continuing. And it doesn't cost a great deal because it doesn't keep track of its message history. It just knows what it has written previously, plus the error messages. So it's good like that. Okay, so this one actually, let's try the art canvas. I mean, you can imagine if the model was a bit better, quite a lot is going to become possible. It's not very good at organize. I mean, it's still quite good, but the organization can use some work. We can increase the brush size, opacity. That doesn't seem to work, but the color color mixture works. Oh, opacity does work indeed. I think it does. Fill shape. So there are these options, but you can't tell which one's which. There are also some options down here. Hmm. Interesting. The fact that it just builds this all on its own is pretty remarkable, nevertheless. You can run it indefinitely. Close. I can't seem to be able to close it. Kill the terminal. Yes. Oh, see, it's having errors. You can try to interact with it real quick. This one is done. What else were we doing? Tetris. We checked out the Tetris is done. We can test it again. See if it had fixed that issue. Oh, the latest isn't working because it tried to refer to a sound file called mo.wave. So it can do that, even though we said it shouldn't. For the most part, until about the latest iterations, it wasn't doing that. 8, 7. Yeah, it still has that issue. It's some sound elements. Let's see. It also, and it kind of really something about it. Just I think the way we are extracting the code from its output was problematic. Let's see simulations of different creatures. We did that. Did we look at the latest version of that? In the folder, 10th one. Oh, that's right. It was having an error. So is it builds more? It can introduce more errors. Not have found enough time to fix it. Yeah, I think we looked at this. Fifth one was the last or fourth. Yeah, this one, and we've seen that. So after the fourth iteration, it wasn't able to, at least not until not until it ended at the 10th iteration, and this was 850 lines of code. We looked at space simulation, Tetris, art creation is done. Let's take a look at the final version of it. Yeah, it looks about the same, but you can zoom in and zoom out. Although something about it might have gotten broken. Oh, you can type in text. So we can actually run this. Let's actually break out of this and delete all this. I'll show you how you can actually interact with it. I'm going to delete all of these, create an assets directory, which we don't need. Let's leave that be. Okay, so for example, we can say a space a simulation of Milky Way galaxy, let's say. So when it starts, it's going to write this code and then run it, but it's going to wait after running. It's going to wait 3 seconds to see if we want to enter Instructions, you press enter within 3 seconds. So you can actually press enter ahead of time to enter additional instructions. So this is what it wrote at first. So you can actually do it. You don't have to do it hectically like I just did. You can actually take your time with it. Let's run the first one and see what it looks like so we can give it some feedback. Oh, it's yeah. Hmm. Right. We didn't say pie game, and so okay. Let's break out of this. Please use pie game, but don't use any external assets. So now, okay, so it should convert it to pie game now. Hopefully, we didn't specify that, so it just used numpy. Okay, now it's game, not numpy. Sorry, matplotlib. Oh, I forgot to press enter. So just make sure it waits 3 seconds. So we missed this iteration, but I did press enter. I hope I didn't press enter twice because then it'll just send an empty message. But we can actually see what it did with the first iteration. Okay, not much so far. Yeah, see, I accidentally clicked twice, so therefore it said no instructions added. So skipped it. But we have the second iteration, which we can take a look. Okay, well, maybe add some more stuff before we get to before we can input some of our instructions. Okay. Now we caught it. So it paused. You can see its reasoning tokens in the latest iteration. It used 1400 reasoning tokens. Let's run the latest iteration. Yeah, it's really trails. Oh, I can zoom in. Okay, please make the simulation more complex and beautiful. It, well, it didn't write much. It said 271 lines of code. So let's press enter so we can enter our instructions. When it comes down, comes to adding additional instructions, you can also point it to the kind of errors that it's encountering. All in all, it can do some great things, but its design sense is not the best. That's what I noticed, especially if you try to code with all one websites and stuff. It just doesn't do as good as Claude, but it can write an incredible amount of code. Look, it reasoned for 3,000 tokens. Let's see what it did. It added about 100 more lines of code. Yeah, this one now has an error. We can actually paste this here, but it also, when it tried to run it, it got the same error anyway. So it's going to now attempt to fix it. So if you give it a task that you know it can do, it can really make that task quite complex. Actually, if you look at the original video of this, which I'll find at my website, O1 autocoder, this one, I actually this one shows actually other full apps that it has built. Like it built a full calendar app. I think that was the one that was 2,000 lines of code. It also built a full tower defense game. So if you want to know more about it, you can actually watch this one as well. If you enjoy my content, you can find my videos at my website, echohive.live. Let's see what happened here. Okay, we wrote another iteration, still the same number of lines of code. Yeah, it's still running into error, so we're gonna just say it ran into the same error. So now it's going to try to fix it. So I have no idea. I haven't tried how we would go about simulating the Milky Way. So we'll let it go until hopefully it works, and then we'll give it some instructions. You can see the total tokens in iteration. There was 6,000 completion tokens and 4,000 prompt tokens, including the error message. Oh, the sixth one is totally wrong. Yeah, I think this is partly due to the way that we parse it. Oh no. I think when something like this happens, it's, attempt to start from scratch, possibly. Let's see what happens on iteration 9. But we're reaching the end of the 10 iterations anyway. But the main idea of autocoder is to, give it some instructions, get the code executed, get the oh, okay, wow, this looked interesting. Let's press enter, although we won't have a chance to update it. But yeah, you see, it restarted itself due to a parsing error on 6 and 7, and it actually did something nice. Well, at least beautiful looking. Yeah, some things are happening. It's not a spiral. Still somewhat nice. There's some movement. Very slow though. Maybe it'll eventually turn into a spiral. Because I can see them moving towards the right side. Okay, 10th one. Let's run this. It's gonna ask you for instructions, but it won't go on anyway. So therefore, we can just run it like this. Okay, here we go. We can space to pause, arrow keys. We can move this around. We can zoom in. It seems. Gee. Well, okay. This is interesting. Is there a reset? Hmm. Very cool. Well, this is what it came up with. So as you can see, you just don't know what it's going to produce sometimes unless you give it detailed instructions. So this whole iteration up till 5 was kind of doomed in a way, but then when we had a parsing error and it restarted itself, then we got something nice in just 200 lines of code. Yeah. So you never know. Very interesting stuff. So I hope I hope you enjoyed this. Like I said, the main principles is to allow it to generate code, parse that code out of its response, run it, If there's any errors, send it back. Otherwise, allow it to improve the code and just keep repeating that. We are also the reason why so many tokens were being used because it also generates an explanation for each iteration. We actually parse that and save it to file as well that is related to each one of the iterations. Also, we're sending the error messages. So, yeah, those can take up quite a lot of. Yeah, you know what? Let me actually take a look at how much this costs. Like, we ran it almost 7 or 8 times for 10 iterations. And I'll tell you how much I got charged for it. So this whole thing cost about $10 or $11. Running it at 10 iterations, 7 or 8 times. So we can say maybe each 10 iteration costs about $1 roughly. Yeah. So with O1 Mini, that is, which is the better model for coding anyway. So they said. Big or small, what's the range? If you're asking for the what should I say, the line of code. If you let it run for a long time, it'll just keep adding to it. And I've seen it reach like 2,000 lines of code. We can actually maybe just for fun run it, but it just takes time, and I have to get going. Like it just keeps adding to it. So it's if you don't interfere with it, meaning if you don't want to input any instructions of your own, you can just set this literally to like 100. Be mindful of the cost that is, because as it writes more code, the cost is going to increase. Uh, it there's no well the limit of output is by the O1 Mini's output context output token limit, which is 64,000. About 20 some thousand of it is reserved for reasoning. So let's say you have 40,000 tokens, which can feasibly get to about 4,000 lines of code. So that is its like theoretical upper limit that it can write a Python script of 4,000 lines of code. Let's try it actually. We'll just do 20. I don't know if it'll go there, but let's ask a Python script with all with functions for all of okay. Let's say a Python script which includes functions to cover all of mathematics, let's say. And let's actually delete these. So this is a this should demonstrate it well because there's just so many, right? It shouldn't run out of stuff to add. So this is just going to be an exercise on to see how many lines of code we can get it to write. Okay, the first one already is 400 lines of code. It is arithmetic, algebra, calculus, linear algebra. See, calculus is very short. Linear algebra, number theory, geometry, statistics. It also has examples of each. It actually ran itself as well. Look, see, it's going for a long time, meaning it's writing quite a lot of code. I'm suspect it's going to pass 1,000 lines of code, I think. See, no errors detected. Requesting code improvements. It's going to take a look at this code and it's going to, oh, wow, 14 total tokens, completion tokens, 11,000. Yeah, look, it passed 1,000. Yeah, see, this is if your situation involves this many lines of code, of course, it's going to be more expensive. But is it roughly from what we ran? If you set the number of iterations to 10, and it remains around 500 to 1,000 lines of code, you can expect each full run to cost about a little over $1. But this, for example, if you were to let it run, might easily reach $3, $4 because it's just going to write so much. Maybe I should have started with something like this. Well, like I said, you can download the source code to this from my Patreon. Link should be in the comment if you're on Twitter, and I'll add it to the YouTube video if I leave it there, up there. It also is going to slow down significantly as it writes more. So in the first iteration, it reasoned about 600 tokens, and second one, it reasoned about 1,200. Let's see what it all included. So calculus remained pretty simple. Linear algebra was expanded. Number theory got expanded. I think geometry got expanded. We can run it actually, see what happens. Because it's going to execute all these. Oh, there is no two. We are at iteration one. See, we can see all of its print statements. Yeah, it's taken quite a long time. Now I suspect it may just pass 1,500 and probably maybe 2,000. Let's see. Yeah, it wrote 1,400. Uh, it didn't reason as much. Its completion tokens were 14,000. So you can see each line of code equates to about 10 tokens, maybe. It expanded calculus a little bit. I think with this, we'll easily, let's see if we can challenge 3,000 lines of code. The most I got it to write was 2,000. Maybe I'll make another stream trying to challenge it to write 4,000 lines of code, which I think it should. As a matter of fact, it can maybe do more than that because, so let's take a look. OpenAI docs. If you go to models and go to O1 mini, max output tokens is 65,500. It says that 20 some thousand tokens is reserved for reasoning. That's why I was assuming 40,000 tokens, but it's hardly reasoning as much. So that'll leave you actually with almost 60,000 tokens worth of code writing. Oh yeah, I know Prometheus. Nice. I'm glad. Glad you found Echo Hive. So in theory, if it doesn't reason to the max of 20 some thousand tokens, it can actually write almost 6,000 lines of code, which would be quite costly. Let's see where I'm at. No, it isn't reflected much. But this is the more it writes, output tokens are the expensive part. Yeah, Cursor is great. I highly recommend it. Look at this. 18,000 output tokens. So that means we are at 1,800 lines. No, we just passed 2,000. Look at this. Something, isn't it? Look at all this code. And the thing is, it didn't run. It it had an error because the calculus class that it created didn't have derivative method. Calculus, yeah, calculus class didn't have a derivative method, but it tried to use it. So now it's going to try to fix it. So this is going to hold us back because now its only goal is to fix this error and not add to it. So this may actually take longer than one imagines, well, hopes. Because when it is an error message, uh, yeah, it just says fix the error. So it's just going to return the same thing, but just going to try to fix the error. I'm just going to add the download link real quick to the YouTube stream while we are waiting on this. Okay, if you're watching from YouTube, I just added it to the description if you're interested. Okay, but at least we've seen, even if we fail to see it, fix these errors, and if you get caught in them, that we see it past 2,000 lines of code. So that's quite remarkable. As just before these models, the most that you could have hoped for was 8,000 token output from 3.5 Sonnet, which was roughly 800 lines. Yeah. Now, GPT-4Os are actually supposed to output 16,000 tokens, but it's very difficult to get them to do that. Okay, we got something, and again, we got an error. Oh, why? Yeah, it reduced the amount of number of lines of code. Why did this happen now? In line 1797. Hmm. Okay, we'll give it another chance. But as it writes more lines of code, it's going to struggle with errors, as we've seen. We'll give it another go, and then we may just end it because this is just going to take too long. Maybe I'll test this separately in my own time. Well, let's see where it goes anyway. I don't know why this error happened. This happens when you're reading or writing files, usually. You can also look at its plan. Are we writing or reading? No. Hmm. I'm just checking that all write file functions in this has encoding set to UTF-8. Yeah, they are. How about read? Yeah. So don't know why that error happened. Okay, it ran into another error, but it wrote another. Oh, okay. It we again hit this. I don't know why this happens because of the parsing method, I believe. Because we are trying to detect these triple backticks and stuff, and the way that it returns the code sometimes causes it to get confused. Okay, well, I guess this is a good place to end it. But we did see it past 2,000 lines of code, so that is something kind of like a record in a way. I think because my last time the app that went beyond 2000 was not. I don't think it reached 2064. Yeah, it kind of reset it itself. Let me check the cost again. So it increased about a dollar, about like $1.20 since we began. It may not be fully up to date, but this is not costing as much. I mean, obviously, a little bit ago we were running four in parallel. No, I haven't been using the new Python, but I would like to. I want to get to it. I like the new um, threading feature without the what is it the lock, the global interpreter lock, the GIL. But other than that, I don't know what all the new features are. Got to take a look at it. Okay, the new iteration is here. and it is 1,375 lines of code. And it already is running into error, so I'm just going to end it. I'm glad we saw it for 2,000 lines of running code. It's just going to struggle as it writes more, but thank you for watching. If you enjoy this, you can find more of my videos at my website. If you do decide to become a patron, you can download all the projects, source codes. Just find something that you like and then click on it. It'll take you to Patreon. I also have consulting tiers if you'd like to talk with me one-on-one or you need any help with your projects. You can check out the different tiers at my Patreon for that. And also, if you're learning Cursor, I have my 1000x masterclass Cursor course. It's 20 chapters of building full apps. First chapter is free. You can preview each chapter for 2 minutes. So there's 25 chapters building like full stack apps, market research app, multimodal RAG system, universal chat, how to get GPT to watch multiple videos at the same time, how to build a memory system. The latest ones are building an all-one tool calling research agent and how to build an all-one Oracle which performs long-form research using Perplexity on any given topic. So these are all not just the code files, but it's a build. It's a whole video that actually building of the app in Cursor, only using Cursor. So that may be of interest to you guys. Well, thank you for watching. I'm going to end the stream now and